3, simplifying rational expressions. We have simplified rational expressions before. It just means simplifying fractions. Okay, right here, here's a very basic one, simplifying a rational expression. We have a ratio of number over another number. This one's very simple because they are monomial over a monomial, and we can cancel out numbers and we can cancel out variables. But we're going to get a little bit more, what do you call it? We're going to get a little bit more extreme, a little bit more fancy with binomials in the denominator. So first example, before we learn how to simplify and whatever, we're going to find the excluded values again. So just like yesterday, we take the bottom, the denominator, 3y plus 1, and we know that that cannot equal 0. So we solve it then, 3y equals -1, and divide by 3, y cannot equal a -1/3. Okay, y cannot be a -1/3. That is our excluded value. In the second one, you'll see that it's a binomial in there, but specifically it's the difference of squares. So if you think about solving that and factoring that, I would factor it to, if you remember, +3 and -3, so b plus 3, b minus 3. And then remember, if the denominator is 0, that means one or both of the two are 0. So set each one equal to 0. So b plus 3 cannot equal 0, and b minus 3 cannot equal 0. So b cannot be a positive or a -3. Okay, those are excluded values. We're going to continue to need that because as we solve rational expressions, these excluded values might end up being one of our solutions, which then nullifies it as an answer. We cannot use it as an answer if one of our roots becomes an excluded value. Okay, so take a look at this one right here. This is a binomial, so we are going to factor it to a trinomial. We're going to factor it to do binomials. So thinking about a product of -5 with a difference of 4, that would be a +5 and a -1. So our excluded values, when we set each one equal to 0 and solve, would be a -5 or a +1. We can't have a -5 or a +1, or we would have a 0 in the denominator. Okay, so now right here we're going to use our rational expressions. The area for the rectangle is 15a to the 4th b squared c. Write an expression that gives the length of the rectangle. Okay, so if we have the width, what would the length be? Well, we take our area and we divide it by our width. So we've got 15a to the 4th b squared c, and we're going to divide that by the 3a squared b. Now this right here is a monomial, so we can simplify. First, looking at the numbers, I'm going to reduce, take a 3 out of 15 and get 5. My pen is running out of ink here. I can take an a squared out, and this becomes a squared because a to the 4th, take away 2. Take a b out, which means I just have b to the 1st, and the c. So nothing in the denominator, or really 1, but in the numerator I now have a 5a squared bc. Gonna have to change pens on you here. Okay, so that is our length, which we got by dividing our area by our width. All right, let's find another one here. The height of a cylinder. Find the height of a cylinder has a volume of 821 cubic inches and a radius of 7 inches, round to the nearest 10. And over here it gives us our volume is pi r squared h. So volume divided by pi r squared would give us h, because really we're using this pi r squared h. So we have 821 equals pi times 7 squared times h. So we're going to divide by pi and then 7 squared to find out what h is. And we're going to just round to the nearest, what does it say, 10th. That's one decimal place, so 821 divided by, and I'm going to put that in parentheses in my calculator, pi times 49, because that's 7 squared, and I'm going to get 5.3 inches. Okay, moving on then, on the back side of this paper, we are going to simplify expressions. We're going to continue doing this. If we can factor them, we always want to do that. Take a look at this one. We can't factor it because they're both not monomials, but what can I reduce out of the 30 and the 25? Hopefully you're screaming, a 5, because that makes this 6 and this 5. Then I can take out one of the x's, which makes that x to the first, and I can't do anything with the z, so I have 6xy to the third in the top, in the numerator, and a 5z in the denominator. So there we have it. Now technically I should give another one. Keep going here. I should say that x and z right here in this particular problem cannot equal 0, because otherwise we'd have a 0 in the denominator. All right, so that's a pretty simple one when we're dealing with just monomials. But when we're dealing with binomials or trinomials, the only way we can cancel is by having products. And the only way to get products is by factoring. So you need to factor when you can. So take a look at example 4. The denominator is a binomial, x plus 4, x plus 2. No way we can factor that. But we can factor the numerator, which is going to be, let's see, we got x and x because there's no coefficient. That's nice. But then we have a negative 8. So we're looking for a product of negative 8 with a difference of negative 2. So that would be negative 4 and positive 2. That's how we get negative 2 in the middle term. And so now I factor the top and I have the factor in the bottom. Okay, so first I want to state the excluded values of x. Well, what can x not be? So x plus 2 can't be 0, which means x cannot be negative 2. And then I simplify, which just means we cancel the factors when they have something the same in the numerator and the denominator. So my answer is just x minus 4. But I have to remember that if I were solving that, x cannot be a negative 2, and we're going to get to that in a little bit. All right, so take a look at this one. Now, in the numerator, we just have a binomial, but we can factor. We can take a 2 out. So the numerator becomes 2 and then times the quantity of r plus 9. And in the denominator, I'm going to have 2 binomials, which is r and r, product of negative 9 with a difference of positive 8. So that would be a plus 9 and a minus 1, which means my r cannot be negative 9 or positive 1. But then when I reduce my numerator and denominator, I'm going to get 2 over r minus 1. So there are your 2 answers. The excluded answer or excluded value or values, and then our simplified version of our expression. Okay, moving on. Getting more and more tougher and tougher. So right here, they kind of give you a hint here. Up here, it says if you have look at binomials that are opposites, and you may be able to take out a negative 1. So if it's 5 minus x, if you took out a negative 1, that would make the x positive and the 5 negative. So if you have an x minus 5, but a 5 minus x, if you take out a negative 1, check this out right here, taking out a negative 1 out of the denominator, it makes it x minus 5. And so then they cancel, and you'd get negative 1 over negative 1, which would be negative 1. Okay, so right here in this one, on top we have 49 minus x. That is the difference of 2 perfect squares. So that would be 7 plus x and 7 minus x. In the denominator, we can only take out a number which would be 5, which would give us x minus 7. So here's where we're talking about that. This is the same except they're opposites. So I'm going to make that a -1, and this becomes x minus 7, which then can cancel with that down there. However, I still cannot have the value of a positive 7 for x, but when I reduce, then I get a -1 here, so that would be -1 x plus 7, because addition doesn't matter, all over 5. And there it is. Let's try another one very similar to that. Check this one out. I'm going to go ahead right away, because odds are it's going to have to be this way. -1, and I'm going to go t squared minus 36, which is going to give me t minus 6. So that translates to t plus 6 and t minus 6. And that's nice because in the denominator, the t minus 6 is going to go bye-bye. But remember, t cannot be a positive 6. But when we simplify that, I'm going to get a -1 times t plus 6 in the numerator all over 5 in the denominator. All right, how's that going? Awesome, awesome, awesome. So now, if we remember, to solve or find the zero is the same thing. Find the zeros, solve for an equation. That's when the function equals 0. So we factor it and we set each factor equal to 0. When we do that with a rational expression, we really, like, think about a fraction. How does a fraction equal 0? It doesn't matter what I have in the denominator. The numerator has to be 0. The denominator can't be 0. So remember, here's our excluded value. X cannot be -2. So when I solve my numerator, because that's the one I care about, then x squared minus 8x plus 7 would have to be 0. So then we factor, and it's going to be plus 8 and minus, sorry, nope. My bad. X minus 7 and x minus 1 gives us 0. So my two possible answers are a positive 7 and a positive 1. Now, my excluded answer was -2, and that's okay. Notice neither one of my roots, neither one of my zeros is -2, so I'm okay. But if you get one where it is one of your excluded terms, then you cannot use it as your answer. I'm hoping this one gives us an example of that. Okay, so first, excluded answers, I cannot get a positive 3 for x, otherwise I would get 0 in the denominator, and that's not a real number. So now I set the numerator equal to 0 and factor and solve. So I've got a product of 18, a difference of 3. That would be a plus 6 and a minus 3. So my possible answers are -6 and positive 3. Here it is. It can't be a positive 3 because then I'd have 0 in the denominator. So that eliminates that as one of my answers. And my only solution for this expression is the -6. So a lot of old stuff, factoring, canceling, and then solving for, setting the numerator equal to 0 and factoring and solving. The denominator is just your excluded values, so really we're kind of just tying everything together. A lot of this stuff is old. All right, so go ahead and work on your assignment. It should be on the back of your page in the yellow notes. You should not need graphs today, so I'm sure you're pretty jacked about that. So 12 through 15, we are just, oh, you're not even doing those, sorry, 17 through 35. So 17, we're doing that word problem, and then through 35, all the way down here. Remember, state the excluded values and then simplify. Down here, you're going to have to give the excluded values, so then you can find the numerator, set the numerator equal to 0, and make sure you don't have any that are the same. All right, that's all I've got. Good luck. Come see me if you got any issues.